Om Shri Sai Ram. Dear children, in this class we will study about the types of polymerization, that another type, that is a condensation polymerization. Before going to this concept, we will do the revision of last class, what and all we discussed in last class. So, in last class we discussed about the free radical mechanism of addition polymerization, then some important polymers, addition polymers. The first one is polyethylene. In polyethylene again two types were there. First one is low density polyethylene. We prepared low density polyethylene by ethene molecule in the presence of dioxygen and peroxide as a catalyst, and 1000 to 2000 atmospheric pressure we used, and 350 Kelvin to 570 Kelvin temperature, and we got the polyethylene, that is a low density polyethylene, and it is used in the insulation of electricity carrying wires and used in the manufacture of squeeze bottles, toys and flexible pipes. And another is high density polyethylene. High density polyethylene is obtained by the addition polymerization in the presence of 6 to 7 atmosphere pressure, 333 Kelvin to 343 Kelvin, and we used triethyl aluminum and titanium tetrachloride as an catalyst. And here it is very important to know that titanium tetrachloride is nothing but Ziegler-Natta catalyst. So, it is very important even for the examination. So, it is used in the manufacture of buckets, bottles, dustbins and pipes. So, next one is polytetrafluoroethene, is nothing but Teflon. We prepared by addition polymerization, that is a polytetrafluoroethene is prepared by tetrafluoroethene in the presence of catalyst in high pressure. So, it is used in making oil seals, gaskets, used for non-stick surface and coated utensils. And next one is polyacrylonitrile, is also we discussed in last class. We prepared this compound, that is a polymer, by acrylonitrile in the presence of peroxide as a catalyst, and it is used for wool in making commercial fibers as Orlan or Acrylan. In this class we will discuss about the condensation polymerization. So, what is mean by condensation polymerization? Condensation polymerization means the polymers are formed by the monomers having bi or trifunctional group. So, it means it is elimination of small molecules also takes place in this reaction. So, we will eliminate, the reaction is eliminate the small molecules like water, hydrogen, HCl, that is a hydrochloric acid, and alcohol. Okay. So, here there are again 4 different types of condensation polymerization we will discuss. So, the first one is polyamides, and second one is polyesters, and third one is a phenol formaldehyde polymers, means bakelite or related polymers, and fourth one is melamine formaldehyde polymers. So, we will discuss one by one. First one is polyamides. Polyamides is nothing but synthetic fibers and also it is a nylon. Okay. And the polyamides will be having the linkage, that is a polyamide linkage. Okay, linkage is present here. Okay, that is NH-C double bond. This is the linkage is present in the polyamides. So, in polyamides also we will synthesize, means there are 2 polyamides are there. First one is nylon 6,6 and nylon 6. There are 2 polyamides. Then first one is nylon 6,6. So, nylon 6,6 is obtained by, that is hexamethylene diamine, and this is adipic acid. So, remember the monomers, this is one monomer and it is another monomer. So, in previous classes I told you already, in addition polymerization the elimination reaction takes, means there are small molecules are eliminating in last as a byproduct here. So, here we know there are 2 functional groups are present in this, and here also there are 2 functional, that is a carboxylic group. Okay, carboxylic acid group is present in adipic acid, and there are amine group is present in the hexamethylene diamine. So, here we are heating these monomers at high pressure we will get that is a nylon 6,6. So, by eliminating water molecule. Okay. So, here this is 1 H from NH2 and OH from the adipic acid. Okay. Here also we are using n number of adipic acid, here also we are using n number of hexamethylene diamine. So, that is why n number of water molecule is eliminating. So, next one is, so here also we will study about the uses of nylon 6,6. So, where and all we will use the nylon 6,6? It is used in making sheets and bristles for brushes and in textile industry. You can see the pictures also, that sheets and bristles for brushes, and in also it is used in the textile industry, means fiber industry. So, next one is nylon 6. Okay, that is also polyamide. So, this polyamide we will prepared by, that is a caprolactam. This structure is nothing but caprolactam. Okay. So, there are CH2, there are 5 CH2s are there and 1 carbonyl group is there and 1 NH group is there, and means it is also having, there are 2 functional groups. Okay. Addition polymerization always takes place by the monomers which are having tri or bifunctional groups. So, we are heating in with water at the 533 to 543 Kelvin, we will get here nylon 6. Okay. So, here the bond will break in between the these 2 functional groups. Okay. So, NH and C double bond O, there are 5 CH2 groups are there, 5 CH2 groups and NH. So, it is closed by the polymer indication, that is N. Okay. So, next one, polyesters. Next one we will study about the polyester. So, polyesters, there is one important polyester is there, that is a Dacron or Terylene, is the best known example for polyester. It is obtained by, or it is prepared by heating a mixture of ethylene glycol and terephthalic acid at 420 to 460 Kelvin in the presence of zinc acetate antimony trioxide as an catalyst. So, here we will write the reaction ethylene glycol. We are preparing the Dacron by ethylene glycol plus terephthalic acid. We will get a Dacron this is Dacron or Terylene. Okay, see here this OH and 1 H from the ethylene glycol is eliminating as water molecule in this reaction. Okay, and it is used in Dacron fibers is crease resistant and it is used in blending with cotton and wool fiber, and it is used as glass reinforcing materials in safety helmets, etc. Remember the reaction, it is very important for the examination also, for 2 marks and all they will ask. So, next one is phenol formaldehyde polymer, means bakelite or related polymers. It is also very important for examination. Here third one, phenol formaldehyde polymer. So, we are reacting phenol. So, this is the phenol structure reacting with formaldehyde. This is the formaldehyde. Formaldehyde, this one is phenol in the presence of acid or base. Either acid you can use or base you can use. So, here we will get this is one compound. So, there are three compounds it gives. So, this is the ortho hydroxy methylene group, this is the para and ortho and para, and here also ortho and para groups are attached here. So, here we will take only this compound. So, by taking again we have to react with the phenol, we will get the ring like structure . So, ring like structure joined by that is a CH2 group, CH2 group. So, this is called as Novalac. Okay, Novalac, it is used in the usually paints. Okay. So, here you just remember it is a long chain. Okay, long chain ring like structure, it is joined by a CH2 group, it is called the Novalac and it is used in the paints. So, here by Novalac we are going to prepare bakelite. Okay, remember the Novalac structure. So, next by Novalac structure we will again heat Novalac, we will get the bakelite structure. This is very important for the examination for 2 marks. They will ask the structure of bakelite. This is the bakelite structure. So, in Novalac we have only this much structure, there is one Novalac, and then when we react with the another formaldehyde we will get the bakelite. Okay. This is the bakelite is very important for examination, they will ask for 2 marks only structure. Okay. And the uses of bakelites are they will use in the manufacture of combs and they will use in the manufacture of making combs, phonograph records and electrical switches and handles of various utensils. So, you can see the even pictures in the screen. Okay, there is combs are there and handles they will use by using bakelite, and even phonograph records and switches, electrical switches. Okay, very important, don't forget this bakelite structure. So, next one, melamine formaldehyde polymer. The fourth one is melamine formaldehyde polymer. This is the melamine we are going to react with formaldehyde. Okay, this is the formaldehyde. So, we will get resin intermediate structure. So, this is the resin intermediate. When we polymerize this, it is a polymerization, we will get melamine formaldehyde structure. This is the melamine formaldehyde polymer. So, see the reaction, this is melamine. When we react with formaldehyde, we will get the resin intermediate. So, see here formaldehyde, there is CHO is there, here NH2 is there. So, here NH, one H will again attached here. So, it will become NHCH2OH, the last one, and next when it polymerized, we will get, so we know in condensation polymerization there is small molecules will eliminate in the last process, so H2O molecule eliminate there. So, we will get, so NHCH2O and here NH and here NH. This is the melamine formaldehyde structure. Okay, it is used in manufacture of unbreakable crockeries. So, sorry, it is a O is not there, because OH plus H from the amine group, it will eliminate as a water here. Okay. So, here only NHCH2. So, this one is used in the unbreakable crockeries. Okay, you can see even in the picture also. So, this is all about melamine formaldehyde polymer. So, here we have discussed there are 4 condensation polymerization till now. There is the first one is the polyamides, polyesters and phenol formaldehyde polymers, means bakelite or related polymers, and next one is melamine formaldehyde polymers. So, I will give some assignment last now. So, questions, see here first question is name the monomers of nylon 6,6, means there are 2 monomers we have used in nylon 6,6, just give the names of those monomers. So, next question is water thermosetting polymers. So, you just explain, just define what is mean by thermosetting polymers. Next one is what is a homopolymer and give an example. So, you know homopolymer and copolymers we discussed, and you just define what is homopolymer and give an example for that. And what is addition polymerization? Give an example for a copolymer here. And the next fifth question is what is Ziegler-Natta catalyst, and sixth one is write a equation for the preparation of Teflon and nylon 6. You have to write the equation here. And next seventh question is name the monomers used in the preparation of Dacron. There are 7 questions are there. We will discuss the answer of these questions in the next class. Thank you. Sai Ram.